This is the 8th topics for the last minute series. It's about circle and triangles. So it means about the circle properties and similar triangles and also the congruent triangles. Okay, so in these examples, A, B, B, C, C, D, and AD are chords. AC and BD intersect at E. And it's given that BE equal to 8 centimeter, CE equal to 20 centimeter, and DE equal to 15 centimeter. So part A, you're asked to write down the pairs of similar triangles and also find the length of AE. First of all, we need to revise for similar triangles. Similar triangles. We need to know there are 3 ways: angle, 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 and the second thing is 3 sides are proportional. Proportional. And the number 3 is 2 sides in ratios and the included angle. Okay, so three ways to prove 2 triangles are similar. Most of the time, you will just apply the first one or the second one. Then you can prove 2 triangles are similar. Okay, in these examples, we can have the angles equal, the corresponding angles are equal to each other because this angle equal to this one, because angles in the same segment. And we also have this angle equal to this angle. So of course we have the vertical opposite angle equal to the vertical opposite angle. So by AAA, we can have a triangle ABE and triangles DCE are similar. Okay, but in part A, you don't need to prove it. You just need to write down up here. Okay, so triangle ABE, which is similar to triangle A corresponding to D, B corresponding to C, E just E. Okay, so ABE is similar to DCE. So after you prove similar triangles, then how to find AE? So AE, or if you already got a similar triangles, then you need to find the length of 1 side or 2 sides. Then you most likely you need to apply the properties of similar triangles. What are the properties of similar triangles? The corresponding angles are equal and 3 sides are proportional. So we try to use 3 sides proportional to solve to find out the length of AE. Okay, so let's see. AE, let me write down the 3 sides proportionals. AB correspond to DC, BE correspond to CE, and AE correspond to DE. So 3 sides proportional. Let's replace it by the values, by the numbers. AB we don't know, so just copy down AB. DC we don't know, so copy down DC. BE we know which is 8 centimeter. CE which is 20 centimeter. AE which is we don't know. DE which is 15 centimeter. So focus on the last 2 ratio. I mean this one and this one. Okay, just focus on this one. This can help us to find out AE. So let me just write it down. 8 over 20 over 8 equal to AE over 15. So just focus on this relationship. It can help us to find out the length of AE. 20 times AE equal to 8 times 15. So AE equal to 8 times 15, 120 divided by 20, which is 6. So AE equal to 6 centimeter. So this part A. Now looking at part B, if suppose AB equal to 10, okay, let's write down 10 there. Okay, just suppose AB equal to 10 centimeter. And we got AE from part A, so AE, which is 6 centimeter. Okay, and then you are asked to prove whether AC and BD perpendicular to each other. So how to prove two straight lines perpendicular to each other? If in coordinate, we can use the slopes. We multiply the slopes of two straight lines, and if the product is equal to -1, then we can conclude that the two straight lines are perpendicular to each other. But here, we do not have coordinates. So if we want to prove two lines perpendicular to each other, we need to prove the angle equal to 90 degrees. So, but the question didn't tell us any angles. That's why we need to find another way to prove two lines are perpendicular to each other. So we have the last way is for right angle triangle, we can apply the converse of Pythagoras theorem to prove our triangle is a right angle triangle. If we can prove it is a right angle triangle, then we have two sides perpendicular to each other. So let's see that AC and BD, AC and BD. So AC is this side. AC is this side. BD is this side. So if I want to prove these two straight lines perpendicular to each other, if I can prove triangle, if triangle AEB is a right angle triangle, then AC perpendicular BD, right? Then AC perpendicular BD. So what we need to do is we are going to prove whether triangle AEB is a right angle triangles or not. So let's do part B. So for converse of Pythagoras theorem, because we already know the length of three sides of triangle AEB, so I just pick up the longest side, which is AB squared. We consider AB squared, which equal to 10 squared, which is 100. Okay, and the other two sides, AE squared plus BE squared. And then I try to add them up, 6 squared plus A squared, which is 36, plus 64, which equal to 100. So as we can see, AB squared equal to AE squared plus BE squared. Therefore, we can apply the converse of Pythagoras theorem to conclude AEB is a right angle triangle by the converse of Pythagoras theorem. So after that, we can conclude that AC perpendicular to BD. Then hence finish. Okay, so we can use the converse of Pythagoras theorem, or use the slopes of two straight line, or find out the angle equal to 90 degrees. So these are the three ways that we have learned in the secondary mathematics. So these are all the ways that we can use to prove two straight lines are perpendicular to each other. Okay, now let's see next example. Okay, in this example, you do not see any circles, so this question is not about circle property. And part A, you're asked to to prove triangle ABC congruence to triangle DCB. So let's revise how many ways that we can use to prove congruent triangles. We have 5 ways. The first way, 3 corresponding sides are equal. The second way, 2 corresponding sides equal, and include the angles, corresponding angles equal. And also we have 2 angles equal and the included sides equal. And also two angles equal and the other sides equal. And also for right angle triangle, we have RHS. Okay, we have 5 ways. So for triangle ABC, which means ABC means this triangle, the blue triangle. Let me shape it. And triangle DCB means this triangle. Okay, let me use green color. So there's something in common. Okay, the red part is in common. Okay, so we need to prove the blue and red, this triangle, is congruent to the green and red, this triangle. So actually in these two triangles there are some common things. Okay, and we know that in the question, let's read the question first. In figure 1, ABCD is a quadrilateral. The diagonals intersect at E, so this point E, and it's given that BE equal to CE, BE equal to CE. So for the triangle BEC is isosceles triangle, we have this base angles are equal. Okay, so actually this base angle is referred to is nice in the triangle BCD. And this angle ACB is for triangle ABC, right? And also the question provide us BAC is this angle, BDC is this angle. So these two angles equal and this two angles equal. Okay, so we have, if we want to prove triangle ABC and triangle DCB, we have the first pair corresponding angles equal. For angle BAC equal to angle BDC, which is given by the question. And also since BE equal to CE, so we have the base angles equal. This is given, and therefore we have DBC equal to angle ACB. Okay, so this is base angles isosceles triangles. Okay, after two angles equal, and also we have BC equal to CB. Okay, so therefore we have two triangles ABC, which is congruent to triangle DCB, which is about AAS. Okay, we have this angle sine. Okay, let me draw it. Angle, and this sine BC. Okay, angle sine. So this for part A, finish. And you can write it better. Consider triangle ABC and triangle DCB at the beginning. Consider, okay, these two triangles. And we have given base angle isosceles triangle and also the common side. Oh, here you need to write down common side. Okay, and two triangles congruence. Okay, now let's look at part B. Part B, consider triangle in figure 1. Consider the triangles in figure 1. How many pairs of congruent triangles? Congruent triangles we have in part A, we already proved triangle ABC congruent to triangle DCB. So we also have triangle AEB congruent to triangle DEC. And we also have triangle ABD congruent to triangle DCA. Okay, DCA. Okay, so we have 3 pairs. So you just need to answer there are 3 pairs of congruent triangles. And B2, how many pairs of similar triangles? How many pairs of similar triangles? We know that congruent triangles are similar triangles, so at least we have 3 pairs. Okay, at least we have 3 pairs. And besides these 3 pairs, we also have triangle. Besides the 3 pair, we also have triangle BEC, similar to triangle these two is equal. We also have these 2 angle equal, these 2 equal, and so parallel alternate angle. BEC, we also have AED. Okay, besides the 3 pairs of congruent triangle, we also have 1 more pairs of triangles which are similar. For congruent triangles, they are automatically similar triangles. And add 1 more pair, so you can answer. You don't need to list them. You just answer there are 4 pairs of similar triangles. That's it. Okay. Let's see another example. In this example, you cannot see a circle, so no need to think about circle property. But in part A, you are asked to find to prove 2 triangles are similar. As I mentioned in the first examples, you can use AAA or 3 sides are proportional. These 2 properties normally. Okay, so in figure 1, D is a point lying on AC such that BAC equal to CBD. So these 2 angles equal. So if these 2 angles equal, you are asked to find ABC. What is ABC? ABC is this triangle, this big triangle ABC. And BDC should be this triangle. Okay, so for the blue and green triangles, they both contain the common angle C here. Okay, so you can consider for part A, consider the 2 triangles, triangle ABC and triangle BDC. So we have angle C equal to angle C. This is the common angle. And the question provides us the angle BAC equal to angle CBD. So this is the given. So the last angle, angle this one and this one, so last angle is ABC equal to 180 minus angle C minus angle BAC. Okay, and the other angles in BDC, which is BDC equal to 180 minus angle C minus angle CBD. So from these 2 relationship, we know that angle C is the same, angle BAC and angle CBD the same, because this part. So therefore, these 2 angles are the same. You can make a conclusion. Therefore, angle ABC equal to angle BDC. So look at this part. this part, and this part. So for these two triangles, all the three angles are equal to each other. Therefore, triangle ABC similar to triangle BDC, which is AAA. Okay, so this for part A. Now for part B, AC equal to 25, BC equal to 20 centimeter, BD equal to 12, BD equal to 12 centimeter, and AC is here, AC equal to 25 centimeter. You are asked that is triangle BCD is a right angle triangle. So how to prove BCD is a right angle triangle? We need to prove use the converse of Pythagoras theorem. But here we do not have this sign CD. We need this sign so that we have the three sides of the triangle BDC. If we have the three sides, then we can apply the converse of Pythagoras theorem. But unfortunately, today the question didn't provide us this important information. But what we need to do is to think about what part A gives us. Part A gives us the similar triangles. So we can apply the properties of similar triangles. Three sides are proportional. So we can say that since triangle ABC similar to triangle BDC, so therefore we have AB to BD equal to BC equal to DC equal to AC over BC. So this is the property three sides proportional of similar triangles. So AB we don't know, we just copy it down. BD we also we know which is 12. BC which we know which is 20. DC we don't know, that's what we want to know. And AC just equal to 25. BC is 20. So we focus on the last two ratio, this one and this one. Okay, we focus on this one, then we can find out the length of DC. So let me just copy it down. 20 over DC equal to 25 over 20. So 25 DC equal to 20 times 20. Therefore DC equal to 400 over 25, which is 16 centimeter. So now DC is 16 centimeter. Now we have three sides. So this is for part B. After we find out the length of DC, then we can apply the Pythagoras theorem. So for applying Pythagoras theorem, we need to pick up the longest side square. So BC square equal to 20 square equal to 400. And the other two sides, AD square plus CD square equal to 12 square plus 16 square. Then we can get it 144 plus 256 equal to 400. So as we can see, this part equal to this part. So you can state that, let me move it up. You can state that since BC square equal to AD square plus CD square, therefore triangle BDC is a right angle triangle, and hence therefore you can conclude that BD perpendicular to, the question just asked us to answer is triangle BCD is a right angle triangle. We already answered here, so we don't need this part. Okay, so finish here. BDC is a right angle triangle. That's it. Okay, so let's see the last example for this topic. circles and triangles. Okay. Now, this is about not related to similar triangles and also not related to congruent triangles. This is about circle properties. So let's see. Let's read the question first. ABCD is a circle. E is a point lying on AC such that BC equal to CE. Okay, so it's given that AB equal to AD, AB equal to AD. Okay, good. Angle ADB equal to 58 here, 58, and CBD equal to 25 degree, and you are asked to find the angle BDC and angle ABE. Let's consider angle BDC first. BDC is here, so we are going to find this angle. According to the circle properties, angles in the same segment. So angle BDC, this angle equal to angle BAC, because angles in the same segment. Also, angle BDA equal to 58 degree. So we also have this angle BCA also equal to 58 degree, because same reason, angles in the same segments. So if we have this angle equal to 58, and also this angle is also equal to 58, because this angle 58, this angle 58, because AB equal to AC, AB equal to AD, so isosceles triangle, so the base angles are equal. Therefore, we can find out this angle BAC, which is 180 minus 58 minus 25 minus 58, angle sum of triangle. So we get this angle. After we get this angle, then we can find angle BDC. Okay, so let me write it down for consider BDC, right? So first of all, we can find out, since angle BCA equal to angle BDA equal to 58, angles in the same segment. And also, since AB equal to AD, therefore the base angle ABD equal to the angle ADB equal to 58 degree. Base angles are isosceles triangle. Therefore, angle BAC equal to 180 minus 58 plus 25 degree, and then minus 58 degree. So we have, using calculator, we can get 180 minus 58 minus 25 minus 58, so we get 39 degree. So angle BAC equal to 39. Therefore, angle BDC equal to angle BAC equal to 39, angles in the same segment. Okay, so this for the first part, to find the angle BDC. And now we are looking at angle ABE. So where's angle ABE? Let me indicate here. Okay, angle ABE. So how to find this angle ABE? Okay, now because we have angle BCE, right? Angle BCE, we got it equal to 58 degree. And since we have BC equal to EC, this is given by the question, provided by the question. Therefore, the base angle, this triangle BCE is an isosceles triangle, so the base angles equal to each other. So CBE equal to angle CEB. So equal to 180 degree minus the vertex 58 degree divided by 2. So which is 122 divided by 2, which is 61 degree. So after we have 61 degree of this angle, this is 61. So we can find therefore angle EBD equal to 61 minus 25, so which is 36 degree. So after we got this 36, this angle equal to 36. Therefore, the angle we need, angle ABE, equal to the whole angle ABD minus angle EBD, which is 58 minus 36 equal to 22 degree. So that's it. Okay, that's the end for the 8th topic for the last minute series. Hope to understand more about the circle properties and hope to help you revise the ways how to prove similar triangles and congruent triangles. Thank you.